Good morning, students. Today we are going to start the next technique, that is chromatography. Who described this process for the first time? It's by a Polish botanist called Mikhail Sweat in 1906. So, what's its application? That's the next point. It is commonly used in separation of both organic and inorganic substances. Organic substances, we know they are carbon containing compounds. Inorganic means carbon absent compounds. And commonly we are use this technique for separating amino acids. Then another term we need to familiarize, that is chromatogram. What is chromatogram? It's usually a visible record. A chromatogram is usually a visible record. Visible record means we can see the result there. A visible record. Record of what? It shows the result of separation. Separation out of a mixture. Because chromatogram is a visible record of what is a result of a separation out of a mixture. That is chromatogram. If we give a mixture down here, after the process, we can get the result of separation as a record, maybe on a sheet of paper or anything like that. Once more, chromatogram. What is chromatogram? Gram is a visible record showing the result of separation out of a mixture. Next slide. What is the principle? Main thing here, the main two aspects that we need to understand is, it has the commonly the chromatographic process works mainly based on the nature of two phases. Which are the phases? A stationary phase and a mobile phase is there. Means a stationary stage is there and also a mobile stage. Two parts are present in that procedure. And how this separation occurs? Separation mainly occurs based on the relative solubility. That term is otherwise called partition coefficient. So, how this separation occurs depends on the relative solubility of the substance in these two phases. Substance means what substance, what mixture that we need to separate into component parts. That mixture, based on its solubility in these two phases, we are separating that mixture. So for finding the partition coefficient, this is a equation that we need to execute while you are performing a chromatography experiment. So we need to by heart this equation. Partition coefficient Kd is equal to concentration of solute. Solute means that substance in the stationary phase to that of concentration of solute in the mobile phase. For both these things, we will get a value at the end of the procedure. So, then we need to understand another property. Whatever the mixture that we need to separate, first in the beginning of the procedure, we need to dissolve it in the mobile phase. And after dissolving that substance in the mobile phase, we are pouring it down through the immobile stationary phase. Understand? So you just think that those have strong, those who are more soluble in stationary phase, what is happening? What is happening to those substances? Those substances means substances have more solubility in the stationary phase. As they have more solubility in the very beginning itself, it may stick to the stationary phase and it will not move much longer in that column. And why consider the case of the other one? Those components have less solubility in the stationary phase. If it is less soluble, then it can move longer distances. Such substances, they move longer. That substances have solubility, but more solubility in which phase? Mobile phase, not in the stationary phase. Understand? Once more. You think the case of stationary phase only for now. Okay? Then consider a substance. It have more solubility in the stationary phase. Such substance cannot move more distance. Then consider components have less solubility in the stationary phase. Such substances, as it is less soluble in the stationary phase, it can move longer distance. That itself is written in another way here. So that separation is based on this solubility of what? That components of the mixture that be taken for separation. Okay, next we are going to see the types of chromatography. And that classification is done mainly based on nature of stationary phase, whether it is solid or liquid. Okay, so if the stationary phase is solid, then you listen to the letters. First letter S, the stationary phase, first letter S. Then the type of that chromatography, first letter A. For easy to remember, just keep it in mind as SSA. SSA. S for solid, S for second S for stationary, and the last A for adsorption. So, those chromatography having stationary phase with a solid thing are called adsorption chromatography. It means chromatography with a solid stationary phase are called adsorption. SSA. Okay. Then the other case, stationary phase liquid. Then what type chromatography it is? It is called partition chromatography. LSP. Liquid stationary phase called partition chromatography. That we need to be thorough in your mind. Don't get confused over the main two classification of chromatography is adsorption chromatography and partition chromatography. Then we are going to study about each type. Adsorption chromatography. Again, we can divide it to two types. Based on what? Because stationary phase, we already know that. Adsorption means the stationary phase is solid. Then what about the mobile phase? Depending on that difference, we can classify adsorption chromatography into a liquid solid chromatography. That means here, stationary is solid. That is given here. Mobile phase is liquid. That type of adsorption chromatography are called liquid solid chromatography. Here the mobile phase is liquid. Examples of such type of chromatography are column chromatography, thin layer chromatography, ion exchange chromatography, so many are there. Next, another type of adsorption chromatography, gas solid chromatography. Here the stationary phase is solid but the mobile phase is gas, called gas chromatography. These are the two types of adsorption. Then what about partition chromatography? Partition chromatography of also two types based on its mobile phase. Its stationary phase is what? Liquid, that we know. So, first type of partition chromatography is called liquid. The second liquid is about the stationary phase. We know it's a liquid, but the mobile phase here is liquid. Example is a paper chromatography. Paper chromatography you will do as a practical maybe in your fifth sum, okay, fifth or sixth sum. So that time if you thorough this process now itself, that time it will be very easy to understand the procedure. Okay, Then second type of partition chromatography is gas liquid chromatography. Here, this liquid is liquid denotes the stationary, and the first word gas denotes the mobile phase. Here, the mobile phase is gas. Then we are going to see about the solvents, which are the common solvents used in chromatography. Solvents means majority means solvents are mainly used as mobile phase. So for what about its composition? How we are forming preparing this mobile phase? Main thing is an organic component. An organic component will be there, then some water, and also along with this we are adding some other chemicals. Well, considering the example for paper chromatography, how we preparing this mobile phase? It is a mixture of butanol, acetic acid, and water. Okay, in the ratio 4 is to 1 is to 1, I think. I leave it. Anyway, that's the composition. How we are preparing that mobile phase, that solvent, with the main, there will be a main organic component, then I have small amount of water and a small amount of some other chemicals. Then location reagents are important thing in chromatography. What is location reagent? There are certain reagents. What is its purpose? To locate the position of separated substance, because from the mixture that components may get separated, but if it is if it is not colored, it is very difficult to be visible. So making it to in a colored for giving it a colored appearance, we are applying this location reagents. Location reagent help us to understand the location of each constituent of the mixture by giving a color to each component. Example, ninhydrin is usually used in paper chromatography. This ninhydrin, after spraying the ninhydrin to the chromatograph, the paper that's showing the result of separation, each components of that mixture appear in a gradation of pink to purple color. That variation, color wise variation we can see, and so on by understanding that variation we can recognize each type of amino acid. Then RF value is another important term. RF value means it is a measurement that measuring the rate of flow of what, of a particular substance in the mixture. So there will be a equation also for determining this RF value. Equation is mainly based on ratio of the distance moved by the substance to that of the distance moved by the solvent. How much distance traveled by the solvent, and also considering the distance traveled by the each component of that mixture. Its ratio is RF value. Here, this is the equation. RF value, how we are calculating? Distance moved by the solute divided by distance moved by the solvent. Solvent means that mobile phase. Then temperature and the type of solvent can affect the RF value. RF value may vary, depends upon the temperature, ambient temperature, the prevailing temperature, temperature of the place where we are conducting that experiment, and the type of solvent. These both will affect the RF value. We will consider if two compounds are there, they have same RF value with a particular solvent, mobile phase. Then what we need to do? If both have same RF value, how can we separate it? In that case, we need to do more chromatography with a different solvent system, because for the same solvent system only these two compounds have same RF value. By changing that solvent system, we can separate these different compounds having the same RF value. So only a exceptional condition. I'm just mentioning about that. Then we are going to learn about adsorption chromatography, its procedure, how that process is carrying out. Adsorption chromatography here uses a mobile liquid or gaseous phase. Get adsorbed into a stationary solid phase. Here, the solid phase is stationary. Sorry, sorry, the stationary phase is solid. The stationary phase and the mobile phase is there in chromatography. In adsorption chromatography, stationary phase is solid. And that stationary phase is called an adsorbent. To that stationary phase, the mixture that need to be separated is mixed in a solvent that acts as mobile phase, and we are pouring over this column. And depending upon its adsorption power to this stationary adsorbent, it moves down. Those have more adsorption power will strongly bind here and will not move down, and those have less adsorption or binding power to this stationary phase move very easily to downwards, and it can be separated first priorly, and later only those substances that bind strongly somewhere here we need to wash out by adding more mobile phase or solvent to here. That is the process, simple. So what is the principle? We are taking a mixture of material that need to be separated, diluted in a solvent. Solvent means that mobile phase that we are taking for that chromatographic procedure. Okay, there is a column is there. That column is first with a solid stationary phase that acts as an adsorbent. And over this we are pouring that mixture dissolved in that solvent, and depending upon its binding property it drains downwards. Those how stronger interaction will remains here. Those are weaker interaction moves more fast towards the bottom end of this column and can be drained out first. And how we can separate those that binds very strongly here? By pouring more solvent to the column. Then that additional solvent will wash out that strongly bonded components later. So in that way we can separate. That washing out of components of mixture that strongly bind here by the addition of additional solvent. That process is called elution, means simply washing out. Okay, that's the principle. Then adsorbent substance, which all used as adsorbent, is a stationary phase here. These adsorbent are certain substances. These substance allow gases, liquids or solid to adhere to its surface without changing the physical properties of these substances. Such materials are used as adsorbent in this adsorption chromatography. With what forces these mixtures bind with this adsorbent? Through van der Waals force, hydrophobic interaction, ionic interactions. Okay, next slide. We are taking some examples for this time. First is how the purification of lipids, how the purification of protein. First we can take the case of lipids. In the case of lipids, for purifying lipids, we are taking the stationary phase composed of silica gel. We are filling the column with the silica gel. Over this, we are pouring the mixture that to be separated mixed in chloroform that acts as a mobile phase. Then it gradually flows down. Those with a stronger bond interaction with this adsorbent or stationary phase will hold here, and those means neutral lipids. They will not bind with this stationary phase and pass out first pass out first and can be separated. And as a result, at the end of the procedure, higher polar ones are eluted. Higher polar means those substances have strong interaction with this stationary phase. They can be eluted by further addition of methanol solvent for washing out the components which have stronger interaction with this stationary phase. Low polar ones are eluted out by acetone. In the case of this purification of lipids. I think you understand that. Then in the case of protein, the same method, and the stationary phase is made up of crystalline calcium phosphate here. Okay. So method is very simple. Just pouring and we are waiting, and how fast the draining out happens depending on the strength of bonding, strength of adsorption, that separation is occurring here. Next. These are two examples of adsorption chromatography, column chromatography and ion exchange chromatography. What about column chromatography? It's an adsorption chromatography. What's the procedure? Adsorbent here composed of alumina or calcium carbonate, CaCO3. Okay, then mixture to be separate. The mixture that we need to separate is dissolved in a solvent like a petroleum ether or hexane or benzene, etc. And depending on its adsorption coefficient, adsorption power for the stationary phase, each components will drains out. Those how less adsorption drains out first, those how higher absorption coefficient drains out only later, and those how stronger absorption power we need to drain out by further addition of more solvent to the column. Then ion exchange chromatography. What's the type? Say liquid solids. Again, an adsorption chromatography. How we understand that is adsorption? Because second term represents stationary phase. Solid is the stationary phase, so it's an adsorption. And here the mobile phase is liquid. Okay. And where it is applicable to molecules like proteins, nucleotides, amino acids, sugars. For separation of all these substances, we are using ion exchange chromatography. What is the principle? Main principle lies in the affinity of these materials to the ion exchanges. So we need to give more stress for the term ion exchanges. Here the stationary phase we are constructing, preparing out of this ion exchanges. So we need to understand more about ion exchanges. Ion exchanges are of two types, anionic exchanges and cationic exchanges are there. Anionic exchanges means they are substances composed of positively charged molecules. Since it is positively charged, it can bind with the negatively charged molecules. So it can separate negatively charged proteins and amino acids. Then cationic exchanges contains negatively charged molecules, so it can bind with a positively charged molecule. So it can be used for separating positively charged proteins and amino acids. Then what are these ion exchanges? Usually they are resins. Resins means they are substances we are obtaining from plant. Usually plant origin, natural origin. And these resins contain electrically charged active sites, maybe positive or negative. Which are used as to form stationary phase ion exchange chromatography. The procedure. These resins we are they are creating in the form of beads, polystyrene beads. We are preparing beads, polystyrene beads out of these resins first, and these polystyrene beads are filled in a column. This acts as the stationary phase, and this polystyrene beads can be of positively charged or negatively charged. If it is of positively charged, called anionic column, anionic ion exchange. chromatography. If it is of negatively charged beads, then it's called cationic ion exchange chromatography. Two type. The two type I am explaining in a common way. Okay. So once more, resins we are using resins we are preparing polystyrene beads. That polystyrene beads can be of positive or negative charge. If it is positive charge called anionic, negative charge called the cationic. That is filled in the column. Then sample to be separated is dissolved in a buffer solution. Buffer solution, we take a buffer solution, and in that buffer solution we dissolve the sample need to be separated, and we are pouring it down through the column. And depending on the strength of the charge, those how, if we consider that the column is an anion filled with anionic beads. Anionic beads means it is positively charged, so it can strongly bind with the negative. Those components, those mixtures have high negative charge will strongly bind to this column, and those have less negative charge will drains out. Okay, so here in this figure they are explaining with which type of an exchanger. Here you see that negative charge. Negative charge means it's a cationic ion exchanger. So since it is a cationic ion exchanger, it has negative charge, so it can bind with positively charged protein or amino acids. So as we are pouring this mixture dissolved in a buffer, those having high positively charged binds with this ion exchanger, and those have negative or least positively charged moves down. And then we need to and this move down negatively charged or least positively charged proteins will be will drains out first. And how we can separate this strong positively charged proteins that bind with these cationic ion exchanger here by pouring more positively charged buffer solution. So here I will give a common example. For instance, you are standing with one of your friend. You have an affection, love towards that friend. Then come another friend of you, and on seeing that friend, actually you have more attachment towards that friend. Then you leave this friend and go to talk and accompany with that friend. The same thing is happening here, because first some strong positively charge is binded to this cationic ion exchanger. Here we need to separate it out. How? We are pouring more positively charged. So as this more positively charged solvent moves down, this ion exchanger bind with that, leaving this one. So secondly, we can drain out this bounded positively charged from the column. So even then yeah, still then some additional positively charged remains to be bind in this resin. What we have to do? Then again we need to pour. Again we need to pour more positively charged buffer. In that way we can wash out all the components separatively in constitutive steps. Understand? That washing out is called elution. This is the procedure. I think you understand that. Then what about its applications? Usually applicable in physiological parameters, like to understand or to isolate the glycated hemoglobin. Glycated hemoglobin means hemoglobin bind with the sugar molecule that present in the body. This presence of this glycated hemoglobin is indicative of diabetes mellitus. Such tests also we can use an exchange chromatography. So measuring porphyrin. Porphyrin also is a constituent part present in some proteins. It present in hemoglobin also. Then industrially also applications are there for quantitative testing of electrolyte. What is the charge of an electrolyte? For quantitative test of electrolyte that are used in electroplating baths. Electroplating means a process of coating a metal layer over some things. That process is called electroplating. These are this application. With this, we finish today's section. Thank you.